Hi class, we are now in chapter 2.7. We are going to start using everything that we've learned so far and start putting it together to solve problems. So problem solving, unit conversion, and specific equation type. We are going to learn some problem solving strategies to help you get started in learning how to break down problems. We're also going to look at unit conversion from using, for instance, 1 foot equals 12 inches. Learn how to identify conversions and how to use them in problems. And also specific equations. So other problems require the use of specific equations. We might need to use additional information. Dimensional analysis is what this is called, and that is to convert between units. So it's a fancy word of just problem solving, but that means that we're using different units. You may start out with one unit and you need to get to another unit as your answer. That's what dimensional analysis is. We're always going to write a number with every unit. Some people, when they first start learning chemistry, they write out the numbers, but they don't write out the units. Trust me when I tell you that is a big mistake. Your unit will help you catch if you're making a mistake. And if you don't use units, you won't always catch that you're basically messing up. Always include units in your calculations. When you divide, when you multiply, you need to do this complete throughout. And don't let units disappear. As you keep going on, and some of these get complicated, keep your units with every step. Guide to problem solving. So the process of problem solving in chemistry requires a few conversion factors. At first, we're going to look at problems with just one conversion factor, but then we're going to start using more and more. And it's easier to do these problems in one big step than to break it up into different steps. It honestly is. Even though at first it may not seem like it, it saves a lot of time as well and less mistakes. So problem solving, we need to identify the quantity, the units, the given units. That's what's given to us as the problem. Then we need to determine the units needed. So that's the units that we may need to get to the end. And the conversion factors, more like stepping stones to get from what you start with to what you need to answer in. So dimensional analysis is usually set up like this. This is very simplistic, and we'll start doing a lot of these problems. You are given information. You're going to multiply that information by a conversion factor. And that's going to allow you to obtain the units you need for your answer. How do you do that? Well, let's say you start out with something here. You're going to use a conversion factor. For instance, 1 foot equals 12 inches. Let's say you start out with feet and you want this in inches. So if this is feet, you're going to use a conversion factor with feet on the bottom and inches on the top. You will cancel out these units. The bottom and the top will cancel out, leaving the units that you want, and that will carry on over to the equal sign to the units that you want is your final answer. So here's a very simple problem to help understand that. So dimensional analysis is what this is called. And you start out with a problem. These are the units you're going to start out with. Your conversion is always should be a ratio of 1, meaning 1 foot equals 12 inches. That equals each other out. So this is units you have to work with, the units you want the problem to end with, and then the units that you end with. So how many feet are in 24 inches? Well, I'm giving you the conversion factor. 1 foot equals 12 inches. So it's kind of like a ladder. You do a little ladder thing, and it's easy if you set it up this way. It really is. 24 inches is what you start out with. Use this conversion, and you use the units on the bottom that you need to cancel out. This is why you write units out. And then you use the units that you want at the top. So now we do our math. 24 times 1 divided by 12 is 2 feet. However, we need to make sure that the units also carry over. So the inches here and inches here cancel out. It leaves us with foot, but plural is feet. 2 feet. We have 2 sig figs here, 2 sig figs here. The one you don't pay attention to, these units right here, 1 foot equals 12 inches is exact. So we really wouldn't even count this. So when you have to answer for sig figs, you're strictly looking at this number here, which is 2 sig figs. So our number should be in 2 sig figs, and it is. Okay, so now let's break down how to do this, because these problems are going to get more challenging. You should have some steps to help you break it down. They may take more time in the beginning, but that's when you need to take the time to understand this. And as you go on, you will be able to just skip this entirely in some cases. If a person weighs 164 pounds, what is the body mass in kilograms? So these are general steps in order to solve this. State the given and needed quantities. Write a plan to convert the given unit to the needed unit. So think of stepping stones. State the equalities and conversions, and then set up the problem. And allow the conversions to set up in a way that the units will cancel out. So, first, state the given and needed quantities. So we are given 164 pounds. That's what we are to start with. We need to get to kilograms. And now, in order to connect this, the stepping stones is we need a conversion that goes from US to metric conversion. So next thing we need to do is we need to write a plan to convert the given unit to the needed unit. So we need to go from pounds, a conversion factor, to kilograms. So now we need to figure out what conversion factors. This is called an equality, and it means they are equal to each other. So 1 kilogram is equal to 2.20 pounds. Now, these are two different numbering unit systems. So these are numbers that would be counted in our sig figs. You don't count the 1, you count the other numbers. So this is 3 sig figs here. So 3 sig figs will have to be considered when we work on this problem, because this is metric and this is not. And then you put conversion factors. You set them up in a way that will allow you to see which one will work with how you solve the problem. So we just solved the problem now. So we have 164 pounds. We're going to use pounds on the bottom to cancel out. We should end up with kilograms. And we end up with 74.5 kilograms. Now let's take a look at this problem completely. We have 3 sig figs here. These are two different numbering systems, so we also count 3 sig figs. You don't count the 1, you always look at the other value. This is 3 sig figs. Our answer will be in 3 sig figs. And we always write the units out. Always. So metric equalities. An equality states that the same measurement in two different units can be written using a relationship between these. So all that means is what is equal to each other. 1 meter equals 100 centimeters. 1 meter equals 1,000 millimeters, and 100 centimeters equals 1,000 millimeters. These are metric equalities. All of these do not count towards sig figs because they are in the same number value system. But this is where the prefixes get sort of complicated, and that's why I'm showing examples, so you help you to understand how you can jump from one metric unit to another metric unit. Metric equalities for length. So if we look at a meter stick, 1 meter equals 100 centimeters, 1 meter equals 1,000 millimeters, and 1 centimeter equals 10 millimeters. So what does this mean? Let's look at this. This whole stick here is a meter stick. That means that it's broken down into segments of 100. So you can see this is 10, 20, and so forth, 100 centimeters. But in this also, these little increments here, all of these equal 1,000 millimeters to a meter stick. And if you take just between, for instance, 1 and 10, which is what you're seeing here, in between these numbers. So 1 centimeter, so if we break it down, we're looking at this number here, this little line. In this 1 centimeter are also 10 millimeters. And that's what you're seeing in here. So all of these equalities equal 1 meter stick. So depending on what you need, you have a lot of leeway into what you need to use. Metric equalities for mass. So again, we have the base unit of grams, but 1 gram is the same mass as 1,000 milligrams, or 0.01 kilograms. Now milligrams is a smaller number, so we expect a larger value. Remember, 1 nickel equals 5 pennies. Or we have a kilogram, which is a larger number, so it's going to have a smaller value to show that it's a gram. 1 kilogram equals 1,000 grams. 1 gram equals 1,000 milligrams. 1 milligram equals 0.001 grams. And 1 milligram equals 1,000 micrograms. Writing conversion factors. We're going to write a conversion factor for 2 units that describe the same quantity. So this is what we showed as 1 foot equals 12 inches. These are the conversion factors. 1 meter equals 1,000 millimeters, and you would set it up how you need to. 1 pound equals 16 ounces, and 2.20 pounds equals 1 kilogram. Now, these are 2 different systems. So the first one is not, this does not count in sig figs. This one is together as well, but this one is not. So this bottom one, you would actually have to count in sig figs. Equalities, conversion factors. So you need to know which things go where. So 60 minutes equals 1 hour, and hour is an H, not HR. You need to know what the denominator is, bottom here, and the numerator, and which way it goes. Same, 1 meter equals 100 centimeters. Do you set it up like this, or do you set it up like this? And basically how you set the problem up, and if you set it up correctly, the units will always cancel out. That's why you write your units, to catch if you've made a mistake. Okay, so the numbers in any equality between two metric units or two US system units are defined as exact numbers. So if you're using conversion factors in US system, then they are considered exact and you don't count them towards sig figs. Same for metric. If you're using units conversions between metric, you do not count them for sig figs. But if you use a unit from US systems and one from metric, then you have to count them as sig figs. You don't count the one, you count the other numbers. A definition are exact and are not used to determine significant figures. That's what this means, is that these are definitions and we don't count them if you keep them consistent. US systems, we don't look at them. If you keep in strictly metric, we don't look at them, but if you go from US to metric, you do. Inequality between metric and US units contain one number obtained by measurement and count toward the significant figures. That's exactly what this means. You don't count the one here, but you will look at this number for the sig figs. And here's just another breakdown of some qualities. Again, I use slides from another class. I think these are a lot more clear to understand and see what the differences are. So that's why you may see that some of these don't match in your book. It's just I think these are easier to read and make sense out of. So, and when you see exact, this is the only one that goes from metric to US that would not count in sig figs. This would be considered as the same as the others. The definitions, they don't count. Everything else here would count as towards sig figs. So metric conversions, 1 meter equals 100 centimeters. So you set it up both ways and then you see which way works for you. But this is two equalities or two conversion factors in the same numbering system. So they're exact. We don't use them to count for sig figs and problems. This is one that will, again, US system and metric. So we would use the 2.20 to count towards sig figs, not the 1. All right, so write conversion factors from the equality for each of the following. And I believe I have these all spelled out. I do. So let's take a look at the first one, liters and milliliters. Now you would have that printout I gave you and you could refer to it to look at the prefixes. I'm just going to jump ahead and tell you what these are. So 1 liter equals 1,000 milliliters. So you write the equality. This is the equality. You make them equal. And then the conversion factors are writing them two different ways, switching the denominator and the numerator so you can see which way you would need to use it. And the second one, meters and inches. So 1 meter equals 39.4 inches. That is the equality. And then you would write it out as a conversion factor two different ways with the denominators and numerators different to see which way you would need to use it for a problem. And the last one, meters and kilometers. That is 1 kilometer equals 1,000 meters. Kilometers is a larger number. And then you write the equality out for it, and then you could see how to use it in a conversion factor. So you have two conversion factors showing which way it is. So basically flip it and show that. In solving problems, always check if the final units are correct. That's why you always write out units. Always write out units. Get into the habit now. 2.54 centimeters equals 1 inch. So that's the equality. Now I'm going to jump to the other side here. You see these are the conversions. And then you can see which way you need to use it for a problem. So if you were given a problem of 44.7 centimeters, but you want inches, now you have centimeters. So you can see that this is the one that's going to go here. And then you cancel out the units and you will end up with inches. And that is exactly what you want. And this is 3 sig figs. This is an exact, so it does not fall into using for sig figs for your answer. Strictly this. And my answer is in 3 sig figs. Solution map dimensional analysis. So in order to, when you're first learning how to do this, it's very easy to get overwhelmed. Take your time and make a map. A solution map is a stepping stone to start out with what you're given to get to the final answer. And make these stepping stones so you can see what you need. And sometimes as we go on, you're going to need multiple conversions in order to get to your answer. So having these stepping stones actually helps you focus and get you comfortable with doing these problems. And then you can research and figure out which equalities you need to get there. Okay, so general problem solving strategy. Sort. Begin by sorting the information in the problem. As we go on, chemistry is like learning a new language. It's complicated, it's hard, so you need to take your time and learn how to pick out information. As chemistry gets more difficult, sometimes you're given way more information than you need, and you have to figure out what the information is. Right now, at this point, that's not going to happen. You'll be given pretty straightforward the problem you need and what's being asked of you. So you start out pulling out the information you need to start the problem. Then you strategize. This is stepping stones. Make a series of steps to figure out how you get from what you start with to what the answer needs to be in. And then you also fill in the conversion factors in those steps. And then solve the problem. Make sure that you have your units on every step and every conversion factor. And you carry out the math. That's one of the things. It's really easy to get confused about what you do in here. So if you have long problems, follow it. Maybe multiply everything on top and then divide everything on the bottom. Follow your plan that's going to help you succeed. And cancel units on the way. Always cancel the units. And then look at your answer. Does it seem to make sense? And as you start doing this, you'll start catching some of this stuff. Like maybe your answer is way too big for what it should be. And that's it.